We're live. Are we live?
Yeah.
Well, it's not going. Yes, it's going. Okay, we are live. Here we go. All right, so today's date, go ahead and put your name. 1/29/18. Okay, it's our review for our first quiz, right? And we really want to do well. This review sheet right here is just like tomorrow's quiz, just like it. And so if we can do this really well, hang on to this, don't lose it, put it in your journal, then tomorrow everybody should be able to get a good grade, okay? So let's go through it. Absolute value graph. We know that the absolute value graphs are these V's. That's the graphs. They're V's, okay? We just want to make sure we put this V in the right place, okay? So first the vertex. The vertex is going to be, ready? Opposite. It's the opposite of the inside. Always the opposite, because a positive 1 value for x would zero it out, right, and put it in its bottom. That's why it's the opposite. So our vertex is positive 1, negative 3, okay? It's got to be the opposite inside because that zeroes it out. So then let's go to 1, negative 3, okay? And there's our vertex. Now we know it's a V. It's a positive 1/4, and that's its slope, okay? So then we start at our vertex, 1, negative 3. We go up 1 over 4, up 1 over 4, 1, 2, 3. Oops, I'm off by a little bit. And I'm going to be off the page. That's okay. And then on the other side, instead of up 1 over 4, it's just the negative of that, right? 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. And our V goes like this, okay? There's our absolute value graph. Okay? And I'm off by one little bit here, but I'll try and fix that. There we go. Okay? Okay? So I'll let you catch up. So first I found the vertex by the opposite. And I don't know if you guys want to write yourself a little note. Put opposite. Okay, opposite of the inside value. And then the negative 3, right? And that gives me my vertex. And my vertex is the starting point of 1, negative 3, okay? And then I have a slope of 1/4. So I went up 1 over 4, up 1 over 4. But then I did the opposite, okay? Thumbs up. Thumbs up. If I get going too fast, will you tell me, please? I do not want to go too fast, okay? Now, domain and range. Domain. It's forever wide, isn't it? It's forever wide, so the domain's got to be x equals all real numbers. I like that symbol. It means all real numbers. And the range is the y values. Starts at a height of negative 3, doesn't it? And it goes up. So the range is simply going to be y is greater than or equal to negative 3. Okay, can we do this? Okay. Okay, now example 2. We're okay for example 2? Okay, example 2. This is also an absolute value graph. So we're going to start off with y equals absolute value, simple. Okay, just start there, okay? Now, it's right at 0 for the x, right? It's right at 0. And I'll write it down. I don't need the 0, but I put the 0 in there just so you guys can see it's at 0. And then it's down 2, right? It's down 2. Now, the slope is up 3 over 1. Up 3 over 1, so I'm going to put a 3 over 1 here. And that answer is fine. That answer is fine, but I might get rid of, I don't really need the 0. I would take this answer. I don't really need the 0 though. So I might write as y equals a 3 absolute value of x minus 2, okay? That's a simpler version. They're both correct, but that's just a simpler version. I would take either one, okay? Because they're both right. Okay, thumbs up on that. Okay. All right, now 3. Here's the one that's a little harder for us, but we can do this. Write this graph as piecewise. Now, you do piecewise, we're looking for pieces of the graph, right? The term piecewise. So I got two pieces. I got this piece and this piece. So I've got equation 1. I've got equation 2. Two pieces, right? So the first piece is a line that goes down 3 over 1, down 3 over 1. So I'm going to go down 3 over 1x. And then its y-intercept is negative 2. Okay, so this first graph goes down 3 over 1, down 3 over 1, right? And its y-intercept is negative 2. The second graph is up 3 3 over 1, up 3 over 1. So it's a positive 3 over 1x. And its y-intercept is also at negative 2. Now to make it a piecewise graph, we're going to have to say where it starts. Okay, they both start at 0. Okay, we got to piece it up, and we're going to have one graph be less than 0, the other piece be greater than 0. So we're going to say this piece is back here where the x values are less than 0. And this piece is where the x values are greater than 0. So I'm going to say if x is less than 0, and this piece is if x is greater than 0. Okay, one is greater than 0, the other is less than 0. Okay, this graph is less than 0, this graph is greater than 0. Yep. Ben's ahead of me. So right here at 0, we have a point, right? So we actually have to count this point. So we got to make sure that we count the point here at 0. Either one of these, but not both. Either one of these, but not both, has to equal 0. So it doesn't really matter which one you want. First or second one? Second one. There it is. It does not matter. If you put this first one, you just have to include this point. Don't include it twice because it wouldn't be a function. You either have to include it here with the equal sign or include it here. Okay? Thumbs up. All right, we can do this. We can do this. All right. All right. Number 4. Okay, graph the piecewise. Now I've got to get a piece of graph paper to do this one. So let's see. We've got a piece of graph paper out here. All right, I'm going to do a piecewise graph for this. Get my ruler out. I get my XY axis in here. All right. So when I do these, the first thing I like to put in are the border points. The borderline. So my borderline is this. These two pieces are connected at negative 2. Okay, these two pieces, because it's a piecewise graph, are connected to negative 2. So I just like to draw a line, an invisible line, at negative 2. Okay, so I just use a Sharpie. Some kids use a pencil or whatever, but it's not part of the graph, it's the boundary line. This is not part of the graph, it's only a boundary line, okay? So put in my boundary line, and I know that one graph is from here back, the other graph is from here forward, okay? So let's check out, what are the two graphs? Well, the first graph is going to be less than or equal to negative 2, but it's at 1/2 x plus 3. Now I got to be careful because I don't want all of this graph. So if I go up to 1, 2, 3, and go up 1 over 2, up 1 over 2, I'm doing this real lightly because I'm not even going to graph this, right? Down 1, back 2. Okay. So here's my line, start at 3 here. Start at 3 here. Up 1 over 2, up 1 over 2. Now this graph goes all the way here, but I don't want all of this. I want the piece that's behind or less than or equal to 2. So I'm going to graph in this line. Put an arrow because it goes forever. I'm going to put an arrow there. Now, because of this equal sign right here, I'm going to make sure that this point has a solid dot because it equals that point. Because of the equal sign right here, put a solid dot here because it equals that point right there, okay? Now the other graph, y equals 4. Well, if it's just y equals 4, it's going to be straight across horizontal line at 4, okay? It's going to be straight across at 4. So I go up to 1, 2, 3, 4, and it's going to be a line that goes all the way across at 4. But I only want a piece of it. I want the piece that goes from here forward. I don't want anything back here at all. Now, it does not, there's no equal sign here, so I put an open circle there because there's no equal sign here, okay? Right. All right, thumbs up. Okay, kind of, sort of. All right, let's shift number 5, okay? Number 5, graph the function and its inverse. So, all right, let's do both. And I'm going to go ahead and try and put one in a different color so you can see the two. So, first of all, f of x equals a negative 2/3 x. So, okay, I can start at 0, right? Plus 0, okay, plus 0. I'm going to go down 2 over 3, down 2 over 3, 2, 3, 2, 3, all right? I'm going to graph that line in. And there's my first graph. That's f of x. Okay, just start at 0. I mean the 0 I drew in, right? But start at 0 and then go down 2 over 3, down 2 over 3, okay? Now the inverse. Let's figure out what the inverse is. So we're going to need an inverse equation also. So let's figure this out. So f of x and y are the same thing. Okay? I just took the equation. I know f of x and y are the same thing. Okay? The only reason we use f of x is, sure enough, that is a function, right? It's a function. So let's go back to y. So when we do an inverse, we switch x and y. We're going to switch x and y. So we're going to rewrite this. So switch x and y. So instead of y, I'm going to write x equals negative 2/3, and instead of x, I'm going to write y, okay? So all I did is I switched my x and my y. Instead of y, I wrote x, and instead of x, I wrote y. Now I solve, okay? Now solving this is a little tricky, but I think we can do it. If I want to solve for y, this divide by 3 I'm going to take care of first. So I'm going to undo the divide by 3. So I'm going to times by 3 because that will undo the divide by 3. Okay, that'll cancel that. So I'll have a 3x equals a negative 2y. And then I'm going to divide by negative 2, divide by negative 2. And I'm going to get an answer of y equals 3 over negative 2x. That's my inverse equation. Okay, that's how I get my inverse equation. I had to switch x and y. I had to switch x and y. And then I had to solve for y. Okay, so I had to solve for y. And that's what I did up there. Now I can graph this. Okay, if I want to graph this, let's see, I'm going to start at 0 again. And I'm going to go up 3, 1, 2, 3, but I'm going to go back 2. 1, 2, okay? 3, 2, 3, 2. And there's my inverse line. Now, again, I'm going to show you the other way to do it also. So some kids have a real hard time solving. You could always just take point by point by point and reverse it. Okay, so for instance, this is the point at 3, negative 2. This is the point at 3, negative 2. Its opposite would be a negative 2, 3. There it is, right? This is a point at 1. Let's see, let's get this one. This is easier. This is a point at negative 3, 2. Reverse negative 3, 2 would be a 2, negative 3. 2, negative 3. There it is, right? That's another way to get the line. Just take all of the points and reverse them, okay? All right, number 6. Thumbs up so far? Okay, number 6. Well, we can graph this. Start up at 8. So you figure each of these is worth 2 points, right? One is the basic graph, which hopefully you can graph, and then the inverse. Okay, let's do number 6. 1, 2, 3, 4, 5, 6, 7, 8, right? Start up at 8. That's my y-intercept. And then I'm going to go down 4, 1, 2, 3, 4 over 1, because it's a 4 over 1. We don't write the 1, but it's there, right? Go down 4 over 1, down 4 over 1, 1, 2, 3, 4 over 1, okay? And I'm going to graph that line, okay? There it is. Okay, there's my original, f of x, okay? So to get the inverse, we could switch point by point by point. In fact, I'll show that this time so you can see the other method of doing it, okay? Right, so let's take each of these points. So here's a point at 1, 2, 3, 1, 2, 3, 4. So it's a 3, negative 4, okay? So if I switch 3, negative 4, it becomes negative 4, 3, right? So I can go 1, 2, 3, 4, 1, 2, 3, okay? There's an inverse point right there, okay? This is the point at 2, 0. And I can switch the point 2, 0 to become 0, 2. You can start to see the line already, can't you? Start seeing the line? I'll do another. This is the point at 1, 1, 2, 3, 4. But if we switch 1, 4, it becomes 4, 1, right? So I'd go 1, 2, 3, 4, 1. Hey, I can see my line. You guys see the line going straight across like that? I can see that line, so I'm just going to draw that line in. Now, here's another way to get the inverse equation. If you get the line graphed correctly by doing point by point by point, switching around, point by point by point, hopefully you know that this equation is going to be a y equals down 1 over 4, down 1 over 4, and negative 1 over 4x plus 2. There's my inverse equation. So you can get the inverse equation by the graph. Or you could switch the variables and solve it, which I'm going to show in just a second. Okay, so either way, I want you to be able to be successful. You can either switch the points, get the equation, right, which is the easier way, or you can just go straight to the equation. I have y equals a negative 4x plus 8. I'm going to switch it, make it x equals a negative 4y plus 8, remember? So this is the other way to do it. There's two approaches. One is to switch the points, graph the line, find the equation. The other way is to switch x and y and solve. So I'm going to go, okay, minus 8, I'll have an x minus 8 equals a negative 4y. Divide by negative 4, divide by negative 4. I'll have a negative 1/4 x plus 2. Same equation I just got from the graph, okay? Okay, Chris, you want to put that phone away for me, please? Thank you very much. I'm sure you're taking great notes, aren't you? Absolutely, good man. Okay, thumbs up on that. Can you do that tomorrow? I don't care which approach you use. For a lot of kids, switching the points is the easiest way. See how that? Switch the points, and draw a line. Yeah, Ben?
Do the people who got A's have to do that?
You guys just have to take a retake tomorrow, okay? So you have one question to take. That's it, right? Okay, turn the page. All right, 6. Easiest question. If you missed number 6, you are not paying attention, okay? Seriously, if you missed this problem, I'm going to send you to the doghouse. I'm going to send you back to algebra. I'm going to send you back to 8th grade, okay? You cannot miss this question. You just switch them. Just switch. You're going to go negative 1, 5. You're going to go 4, 3. You're going to go 4, 1. You're going to go 7, negative 2. Now, this is not a function. That's why they use the word relation. It is not a function. Because you see that 4 is paired up to 2 things, right? You can't buy 4 lattes. Can't buy 4 lattes for 2 different prices, can you? So it's not a function, but it is a relation. Okay, that's all you got to do. Switch them. Nobody better miss that one, right? If you miss that one, I'll be so bummed for you. Okay, last but not least. Almost there. So, when you order in bulk, like most companies, if you order in bulk, the more you order, then the prices get less. Does that make sense? Right? If I want 1 t-shirt, they're going to charge me a bunch. But if I want like 100 t-shirts, we get a discount. Or in this case, water bottles, right? If I want 1 water bottle, then it costs a lot more money for the package to get out. But if I order 100 or 200 or 300 water bottles, mass bulk, they'll lower the price. So you can see that to order less than 50, it's 50 cents a bottle, plus the 20. The 20 is the shipping. Does that make sense? If I order from 50 to 100, it's 40 cents a bottle, so the price has gone down by 10, right? Still got to pay the shipping, though, right? As I order from 100 to 200, it's 25 cents a bottle, right? So the prices get cheaper as I order more in bulk. And finally, if I order over 200, it's only 15 cents a bottle plus the shipping, okay? So let's say F of 150. F of 150 is like ordering 150 bottles, right? So 150 would have to go in this one. Does that make sense? The 150's got to go in there. So I'm going to go 0.25 times 150 plus 20. I'm going to use my calculator. Come on, is it not going to work for me today? Okay, this one's dead. Hold on. Let's find a calculator that's going to work for me today. Okay, there we go. 0.25 times 150 plus 20. Okay, I get $57. 57, there we go, dyslexic, $57.50, okay? So if we order 150 bottles, it's only going to cost us $57.50. It's not bad. If we want 50 bottles, now where's 50 going to go? Is it going to go in the top one or second one? Okay, Ben says the second one. Why does Ben say the second one? Why does Ben say in the second one?
Sorry, I can't.
Yeah, of course you can, yeah. Why am I going to put it in the second one?
Because it's equal to 50.
See the equal to? So it's got to go, it can't go in that one, but it goes in this one. So this is going to go into that one. So we're going to go 0.40 times 50 plus 20. 0.4 times 50 plus 20. Oh, darn this calculator, I keep grabbing the wrong one. 0.4 times 50 plus 20. Okay, $40. And then finally, in words. In words, what does f of 50 mean? Or bottles in this case, yeah. So it's really the cost of 50 bottles. That's all it is. It's the cost of 50 bottles. That's what F50 means. Find the cost of 50 bottles. And what's the cost? $40, okay? Okay, so there it is.